Something strange happened when 3i Atlas crossed the Sun. Instruments went silent, cameras turned away, and what should have been ordinary geometry around Mars became a stage for the impossible. A triangle formed in space so precise it felt designed. A second object appeared at the same time, stealing attention like a perfect distraction. Mars itself began to hum, its magnetic field pulsing in rhythm with something unseen. Then the light vanished, the cameras blinked, and when vision returned, 3i Atlas was faster, brighter, and silent. Its tail reversed, its path changed, and moments later, a ripple spread across the solar system, shaking planets and skies in patterns too precise to dismiss. Tonight, we follow that sequence of silence and motion, uncovering the story hidden within the data. What if what we witnessed was not coincidence, but the first act of something unfolding across our side of space? In the quiet vacuum of space, geometry should mean nothing. Yet there are moments when the positions of worlds and objects appear to draw a pattern, too exact to dismiss. During the brief alignment of 3i Atlas Mars and the Sun, an invisible triangle emerged that caught the attention of analysts across observatories. The lines connecting them were not random. They formed a near-perfect isosceles figure stretching across millions of kilometers. The geometry was so precise that it almost looked designed. When data from the Mars Reconnaissance Orbiter confirmed that this formation occurred during a narrow 3-hour window, the coincidence began to feel engineered rather than cosmic. Scientists were careful not to suggest intent, but the timing was hard to ignore. As 3i Atlas approached its closest point to Mars, the Sun sat at a position that allowed the object to use both bodies as gravitational levers. Such a setup is extremely rare. Some called it an alignment of opportunity, while others called it a maneuver corridor. If an object wanted to change its course without detection, this would be the ideal stage. The gravitational influence of Mars could be used as a subtle deflector, while the blinding light of the Sun could conceal the shift from telescopes on Earth. Geometry, in this sense, becomes not only coincidence, but camouflage. The data from the alignment window revealed something stranger. Observations from the European Space Agency showed a faint signature of outgassing, but it was uneven, directed toward Mars rather than away from the Sun. Comets normally release gas in the opposite direction of the solar heat source, creating tails that trail behind or curve outward. In this case, the release faced toward the planet, aligning perfectly with one leg of the triangle. The vector was too symmetrical to be dismissed as random venting. It looked like propulsion, but natural outgassing should not produce thrust patterns that stable. It raised the question no one wanted to ask: could this be controlled? While mainstream science avoided the term control, discussions behind closed doors turned speculative. A hidden maneuver at such proximity to Mars would demand incredible precision. Using planetary geometry for acceleration or deceleration is an old concept in spacecraft navigation. Yet seeing an interstellar object appear to mimic that method unsettled researchers. Some argued that the object might be hollow or have an unusual mass distribution that caused these path corrections naturally. Others pointed to the fact that the geometry of its approach mirrored theoretical models used in gravitational slingshot simulations. The triangle over Mars, they said, was not just a coincidence of position, but a possible key to intention. The question then shifted from what happened to why it happened at that moment. Mars was approaching opposition, a period when the planet shines brightest from Earth. Telescopes around the world were focused on it, capturing vast amounts of data. The alignment ensured that if anything occurred between Mars and the Sun, it would be hidden behind intense glare. The window of invisibility was narrow yet perfect. If someone wanted to execute a maneuver unseen, this was the moment to do it. By the time the geometry broke apart, the object was already altering its trajectory slightly, moving on a path that confused prediction models. NASA's orbital simulations began to diverge from ground observations. The numbers refused to settle. As astronomers worked to reconcile the discrepancies, they noticed that the triangle's formation corresponded with a faint electromagnetic disturbance detected by the Mars atmosphere and volatile evolution mission. Manoeuvre recorded a series of minor spikes in its magnetometer readings during the same hours the geometry held steady. These fluctuations were subtle, almost hidden in background noise, but their timing mirrored the event. Some suspected solar interference, yet the solar output at that time was unusually quiet. The pattern repeated 3 times in perfect intervals. If this was coincidence, it was an elegant one. Speculation spread quickly among amateur astronomers who tracked 3I Atlas through open-source telemetry feeds. They noticed that each time the alignment shifted toward equilibrium, data packets from certain monitoring satellites were delayed or incomplete. The gaps were short but rhythmic, as though the transmission itself had passed through interference. Some thought it might be atmospheric conditions or software issues. Others believed that something had caused intentional disruptions to obscure the event. When ESA later admitted to temporary data loss during the alignment, the theories multiplied. Was this an innocent technical error, or was the geometry itself influencing communications? In the weeks that followed, public attention waned as other cosmic stories took the stage. Yet a handful of researchers continued to map the geometry over time, tracing its evolution as the triangle dissolved. They noticed that the pattern, when extended, pointed to a future position in space between Mars and Earth that 3I Atlas would reach months later. The object seemed to be navigating through precise angular relationships, as if following coordinates only it understood. This geometric breadcrumb trail became known quietly among those studying it as the Mars Gate hypothesis. The idea was simple yet unsettling, that the triangle was not a coincidence but a marker, an entry point for something more deliberate. To test this, simulations were run using the exact orbital mechanics from that day. When scientists removed Mars from the equation, the path of 3I Atlas drifted unpredictably. But when Mars was included, the course stabilized, suggesting gravitational dependency far beyond what standard physics could account for. Some proposed that the object carried mass concentrations aligned to exploit such forces. Others whispered of artificial stabilization. What made it more puzzling was that the object's rotation appeared to slow during the triangle window, as if conserving momentum or redirecting energy. No natural cometary model could replicate that effect without invoking unseen forces or hidden physics. As the object moved away from Mars, the geometry faded and so did the anomalies. Magnetometer readings returned to baseline. Communication gaps stopped. The light curve normalized. It was as if the universe had briefly held its breath and then exhaled, yet traces remained. The triangular coordinates left subtle imprints in the memory of instruments, patterns of timing that could not be erased. Those who studied them began to see the alignment not as an isolated event but as part of a larger map, a roadmap that perhaps extended beyond Mars itself. If the Mars Gate hypothesis is ever proven, it would redefine how we interpret cosmic coincidences. It suggests that geometry in space might not always be the product of chance, but of choice, that the universe might hold configurations of intent waiting to be recognized by those who dare to look. Whether 3I Atlas acted alone or as part of something greater remains a question suspended in silence. But as long as that perfect triangle once hung between Mars and the Sun, it leaves behind a whisper that geometry can be more than math. It can be message, and somewhere within that fleeting shape over the red world, the story of 3I Atlas continues, unseen but not forgotten. While the world watched the skies for updates on 3I Atlas, attention began to drift elsewhere. A new object appeared in the data streams around the same time, smaller, dimmer, and seemingly unrelated. It was catalogued as a routine near-Earth visitor, a harmless comet fragment trailing a standard elliptical path. Media outlets picked up the story, labeling it a curiosity that might brighten the sky in coming weeks. What went largely unnoticed was the timing. The decoy's rise in visibility occurred during the exact days when 3I Atlas entered its most critical phase near Mars. For the casual observer, the shift in focus looked like coincidence. But for those studying the data, it felt like misdirection. Every major telescope suddenly pivoted its gaze. The public feeds filled with commentary about this second object, while the name 3I Atlas began to fade from trending lists. Even the daily updates from observatories seemed to prioritize the new discovery, offering fresh images and light curve measurements, while the primary target slipped into silence. It was as though the stage lights had been redirected, casting the once central figure into shadow. The timing was uncanny. The distraction arrived at the exact moment when 3I Atlas crossed behind solar glare, a period already notorious for communication blackouts. This overlap ensured that by the time it re-emerged, data analysts and public interest had shifted entirely to the wrong place. When archival footage was reviewed weeks later, strange inconsistencies appeared. The decoy object, which should have been far less active given its size and distance, exhibited outgassing spikes exceeding that of much larger comets. The shape of its tail fluctuated in a manner that suggested rapid, directional changes, almost as though it were responding to unseen forces. No one could explain why it brightened and dimmed so abruptly, or why its dust emissions aligned almost perfectly with Earth's orbital plane. The geometry created a veil reflecting solar light in a way that masked part of the sky directly where 3I Atlas should have been visible. It was a curtain of cosmic light, and the timing of its appearance could not have been better engineered. Some researchers proposed that this second object was nothing more than a fragment of 3I Atlas itself. If the original body had split earlier, one fragment could have moved ahead, creating a trail that conveniently diverted attention. Others suggested the opposite, that it was unrelated entirely, but used as a visual and narrative distraction. The evidence for the latter grew when analysts noticed overlapping observation windows where both objects shared near-identical trajectories for short intervals before diverging. The orbits did not make sense. Their apparent intersection was more symbolic than physical, like two paths designed to confuse the viewer watching from afar. NASA's tracking logs added another layer of confusion. During this same period, several of their smaller space telescopes entered calibration modes, pausing normal data collection for system checks. The reason cited was maintenance and software updates, but the timing aligned perfectly with the period of visual overlap between the two objects. The same days when high-resolution tracking could have confirmed or disproved the connection were lost to a technical blackout. When those instruments came back online, the decoy had faded and 3I Atlas had already altered its path. By the time both could be seen again, the story had moved on. Meanwhile, social media and astronomy forums filled with speculation about the smaller comet. Amateur astronomers shared countless images and analyses, debating its brightness and composition. The excitement was genuine, but unknowingly it helped to redirect the conversation away from the main anomaly. This is what made the decoy so effective. It was not a deliberate deception in the traditional sense. It was an organic distraction, an object whose appearance allowed for a convenient redirection of attention at the exact right time. In the world of cosmic observation, where only a handful of instruments can capture full-spectrum data, even a few days of misfocus can alter the public record forever. When independent researchers attempted to reconstruct the timeline, they realized something startling. The decoy's orbital data appeared incomplete in several international archives. Segments of its positional information were either blank or substituted with placeholders, as if the data had been uploaded before final verification. In one case, a European observatory file listed the same timestamp twice for two different coordinates, an error rarely seen in professional logs. These duplications occurred precisely when 3I Atlas was closest to the Sun, the same interval when its tail was reportedly behaving in ways that defied known physics. The overlap between these irregularities made skeptics uneasy. Were these clerical errors or signs of manipulation to create confusion? The deeper the timeline was examined, the more questions arose about the behavior of those managing the data. Some astronomers admitted off record that during this period they had been asked to prioritize certain observation windows over others without clear explanation. Funding allocations for imaging time suddenly shifted. Access to key instruments became restricted. While no one officially confirmed coordination between agencies, the pattern felt orchestrated. It was as though someone wanted to ensure that, for a brief but crucial window, all eyes were turned in one direction, while the real event unfolded in another. The phenomenon was later dubbed the decoy stage by those who studied it. The phrase captured the essence of what many suspected had happened, a diversion, either by chance or design, that caused the world to look away. The eerie part was how naturally it unfolded. There was no conspiracy needed when timing alone could produce the same result. The universe itself provided the perfect stage. All it took was coincidence layered upon coincidence, and the audience would willingly follow the brighter object. In cosmic terms, it was the oldest trick in the book, but not everyone believed it was coincidence. A small group of astrophysicists began examining solar data from the same period, focusing on coronal activity. They found that during the peak visibility of the decoy object, the sun released a narrow, directed burst of radiation that illuminated its tail while leaving the surrounding region comparatively dark. This made the smaller body appear much brighter than expected. If this was a natural solar event, it was extraordinarily precise. If it was something else, it suggested interaction. The fact that the beam-like burst occurred only once and never repeated for any other body in that area deepened the mystery. As weeks passed, both objects faded from mainstream coverage, but a peculiar silence lingered. Some amateur observers who had posted early footage of 3I Atlas's light fluctuations began to report copyright claims and removed videos. They were told that the images contained proprietary calibration data from satellite sources. The claim was technically correct but rarely enforced before. This made others suspect that someone wanted those early images off the web. What they showed, according to those who saw them before deletion, was a faint glimmer on the opposite side of the decoy's tail, a flicker that did not belong. It looked like movement behind the light, a shadow where no object should have been. By the time the data flow stabilized, 3I Atlas had shifted course slightly again, just enough to throw off long-term projections. The decoy, now reduced to a fading smudge, disintegrated quietly without further notice. Yet its brief existence had achieved something remarkable. It had drawn the collective gaze of the planet away from the main anomaly during its most critical hours. Whether by accident or design, it had played its role perfectly. The result was the same. When the triangle over Mars began to dissolve, no one was watching. The decoy that took center stage remains one of the most overlooked episodes in the 3I Atlas timeline. It demonstrates how fragile human observation truly is, how easily global attention can be redirected by brightness and timing. In space, where silence and light play constant games, it is almost impossible to tell performance from coincidence. But for those who study patterns and alignments, the decoy was not just a passing comet. It was a curtain that rose precisely when the real story began and fell before anyone realized what had been hidden behind it. When the alignment between 3I Atlas and Mars began, a strange rhythm quietly emerged from the data. It was not visible to the human eye, but hidden deep within the electromagnetic noise recorded by instruments orbiting the red planet. Maven, the Mars atmosphere and volatile Evolution mission, had been monitoring magnetic field fluctuations for nearly a decade without significant surprises. Then, during the window of the 3I Atlas alignment, something unusual happened. The readings began to pulse at precise intervals, forming a pattern too organized to dismiss as random. These were not ordinary magnetic oscillations caused by solar wind. They came and went like a faint heartbeat, steady, deliberate, and entirely out of sync with the surrounding cosmic environment. At first, the anomalies were buried in raw telemetry, nearly invisible. It was only after analysts cleaned the data that the pattern revealed itself. 3 peaks evenly spaced, followed by a brief silence, then a stronger surge that returned the sequence to its starting point. Over and over again, the same rhythm repeated across several hours. To most researchers, it looked like interference. But interference requires a source, and none could be found. The sun was quiet. Solar radiation levels were normal. The Martian ionosphere was calm. Yet the magnetometer insisted that something invisible had brushed against it in waves, leaving behind measurable footprints. The location of the field fluctuations added another layer of curiosity. They were strongest over Mars's southern hemisphere, directly above a region known for its ancient magnetic crustal anomalies. These are remnants from a time when the planet once had a global magnetic field. Most scientists believed these relic fields were inert, incapable of producing dynamic behavior. But during the 3I Atlas event, the relics stirred. The signals seemed to rise from the old magnetic scars and then dissipate into the thin Martian atmosphere. It was as if something beyond Mars had reached in and tugged on the planet's forgotten memory. When news of the readings leaked into academic circles, debates erupted. Some dismissed the pattern as an artifact of data compression. Others argued it might be caused by temporary electrical interference from solar particles bouncing off the spacecraft itself. But when MAVEN's backup instruments operating independently showed the same pulse at the same moment, the theory of instrument error began to crumble. Even stranger, a second spacecraft, the European Trace Gas Orbiter, recorded a simultaneous fluctuation in its plasma density readings. 2 separate machines, 2 separate missions, one shared anomaly. Whatever happened, it was not confined to a single piece of hardware. Curiosity grew when ground-based telescopes tracking 3I Atlas reported a brief dimming event occurring within the same hour of the magnetic spikes. The comet's light faded slightly, then recovered, as if it had rotated to reveal a surface feature that absorbed sunlight rather than reflected it. The coincidence was impossible to verify but too exact to ignore. If the 2 events were connected, it would mean that the object had interacted with Mars, not physically, but magnetically. The whispers in the Martian field, as some began to call them, were the first potential sign of that connection. To understand what could cause such a signal, researchers turned to the data archives of past interplanetary encounters. Nothing matched. Even during the close passage of massive bodies like comet-siding Spring in 2014, Mars had not shown a pattern this rhythmic. Natural magnetic storms were chaotic and irregular. This one followed a sequence that looked almost mathematical. Some scientists, unable to resist curiosity, converted the magnetic frequency into sound. The result was eerie, a soft, pulsing hum that repeated like a coded message. To the trained ear, it resembled modulation, the kind used in communication systems. No one dared to suggest intent, yet the resemblance unsettled everyone who heard it. The hum raised a new hypothesis. Could the interaction be a form of resonance between 3I Atlas and Mars's ancient magnetic structures? Resonance can amplify small forces into large effects, much like how a singer can shatter glass with a perfect note. If the object emitted any electromagnetic signature, even a weak one, it might have triggered oscillations within the Martian crustal fields. In that case, the whispers were not messages but echoes, the planet itself responding to a cosmic frequency. However, the frequency in question did not align with any known natural range. It fell between categories used to describe cosmic radiation and man-made radio emissions, an uncomfortable middle ground that left scientists unsure which world it belonged to. As the event continued, instruments on Earth began noticing faint correlations. Radio telescopes scanning the same sector picked up periodic distortions in background signals. They were minor, almost indistinguishable from noise, but when synchronized with the MAVEN timeline, they aligned perfectly with the magnetic pulses. The distance between Mars and Earth should have delayed any shared phenomenon by several minutes. yet the signals appeared simultaneously. That suggested something else, something faster than conventional propagation, connecting both points. Perhaps a shared field effect, or something threading through space in a way not yet understood. Speculation moved quickly from science into philosophy. Some theorists wondered if 3I Atlas was not emitting energy at all, but responding to something already present within Mars. Ancient magnetic remnants, they argued, could act like stored memory, reawakening when stimulated by specific frequencies. If so, the object might have been scanning the planet rather than influencing it, probing its field for resonance signatures. This idea unsettled many because it framed the event as an act of measurement. And measurement in cosmic terms implies awareness. In the days following the alignment, the pulse faded. Maven's readings returned to baseline and the whispers were gone. Yet their aftermath lingered in the data logs. When analysts compared earlier magnetic patterns to those recorded after the event, subtle shifts appeared in the baseline frequency of the Martian field. It was as though the planet's magnetic fingerprint had changed slightly, a few micro-teslas off its original value. Such shifts are rare, especially over short timescales. Whatever passed through Mars left behind a faint residue, a ghostly alteration in the invisible threads that wrapped the planet. Meanwhile, curiosity turned toward the nature of 3I Atlas itself. Observers noticed that in the days following the whispers, its rotation period slowed slightly by just under 0.5%. For a body millions of kilometers away, this seemed negligible, yet in cosmic dynamics, such a change implied energy exchange. If the object had emitted a magnetic field strong enough to affect Mars, it could have absorbed feedback in return. A resonance interaction between two bodies of vastly different scales would create precisely this kind of mutual adjustment. Each would take a small piece of the other's rhythm, leaving both subtly altered. The whispers soon became the center of a quiet controversy. Some agencies wanted to classify the readings as background noise to prevent speculation. Others pushed for open publication, arguing that suppressing anomalies only hindered understanding. In the end, the data was released, but buried within technical appendices few would ever read. Only independent analysts brought it back into public discussion, comparing it to other unexplained magnetic phenomena recorded near Venus, Earth, and even the Jovian moons. In every case, the frequency pattern showed familiar ratios, but none as perfect as the one over Mars. Years later, when the term Mars Gate resurfaced to describe the strange geometry of that alignment, researchers revisited the whispers with new context. The realization struck many that the magnetic pulses had occurred precisely within the coordinates of the triangle formed by 3I Atlas. Mars and the Sun. The rhythm, the geometry, and the timing all shared one root moment. It was as if space itself had briefly sung in harmony, using magnetism as the voice. The song was faint and brief, but it carried the weight of something deliberate. In the end, no one could explain the whispers in the Martian field. They could have been natural echoes of forgotten planetary magnetism, or the side effect of an object behaving in ways not yet understood. But to those who listened to the converted hum, the experience lingered. It felt less like data and more like communication, a language without words that spoke through resonance and silence. If there was intent, it was buried deep within the static. Yet even without proof, one truth remains difficult to ignore. When 3I Atlas passed by Mars, the planet responded. It hummed back, and for a few hours, two worlds shared a frequency no one can explain. The moment 3I Atlas crossed the threshold between visible and hidden space, the cameras that had followed it for months began to fail. Some went dark for seconds, others for hours, each failure dismissed as coincidence or routine calibration. But the timing lined up with mathematical precision. Every major observation window that could have caught its most revealing moment closed at the same time. It was as if the sky itself had chosen to blink. The first signs came from the Mars Reconnaissance Orbiter, which had been scheduled to capture high-resolution images of the region where 3I Atlas appeared to pass near the Martian orbit. Minutes before the alignment, its imaging sequence was paused for what the mission log described as a memory buffer reset. The camera restarted hours later, long after the opportunity had passed. The gap was not long enough to draw suspicion on its own, yet when similar pauses appeared in other observatories' logs, the pattern grew impossible to ignore. The Solar and Heliospheric Observatory, one of the oldest and most reliable solar monitors, experienced a data transmission delay during the same period. Its wide-angle lens, which captures coronal activity and passing objects near the Sun, reported a sudden increase in pixel noise that corrupted entire frames. Engineers later explained it as radiation interference, but the radiation levels at that hour were below the threshold that usually causes such errors. A brief spike, perfectly timed with 3I Atlas's closest approach to solar glare, erased several critical frames that could have shown the object in transition. Then came the most puzzling anomaly. NASA's Deep Space Network, which handles communications for multiple spacecraft, registered unexplained data congestion during the same time window. Signals from unrelated missions arrived scrambled, and automated systems temporarily prioritized bandwidth away from the Mars region. This meant that even if one of the probes had recorded the event, the data would not have been transmitted in real time. The universe had offered a clear stage, yet every instrument turned its gaze away. When researchers compared the gaps in the footage, the synchronization was too clean to ignore. Each camera outage overlapped within seconds, forming a narrow corridor of missing data that spanned agencies, continents, and even private observatories. Amateur astronomers who had been recording through solar filters reported their own interruptions. Some saw equipment overheat without warning, while others described software freezes that forced system reboots. The statistical odds of this many failures across independent systems were nearly impossible. The silence of the cameras became louder than any image they could have captured. In the following days, agencies scrambled to provide explanations. Technical notes cited everything from cosmic ray strikes to automated safety protocols, yet none of those causes accounted for the collective timing. Engineers who reviewed the telemetry discovered something else. In several instruments, the command to pause imaging had come from automated triggers that were never manually activated. The systems seemed to have responded to a stimulus that was never logged. It was as if the cameras had detected something they were not designed to interpret, something that forced them to shut their eyes. The missing frames ignited a quiet panic within the scientific community. Everyone knew that space is unpredictable and that data loss is inevitable, but never before had so many instruments failed at once during an event of this significance. For those watching closely, it looked deliberate. Some believed the radiation interference theory, but others pointed out that radiation tends to scatter randomly. These gaps were not random. They formed a sequence, a chain of blind spots arranged across the very path Atlas was expected to follow. Independent researchers began reconstructing the event using peripheral data. By analyzing the light curves before and after the blackout, they noticed subtle deviations in brightness, suggesting that the object may have changed shape or orientation. If true, this could have revealed more about its structure than any photograph. The fact that the cameras stopped exactly when this transformation might have occurred added to the unease. It was as though the event itself resisted being documented, a self-shielding moment that evaded mechanical perception. A few weeks later, leaked internal correspondence from one observatory hinted at something more unsettling. One engineer described an unexplained feedback pulse that caused the imaging sensors to enter protective mode. The pulse appeared to originate not from the Sun, but from the same coordinates where 3I Atlas should have been. This suggested that the object emitted a burst of electromagnetic interference strong enough to blind nearby detectors. If so, it would have required a level of energy output inconsistent with a passive comet. The words were buried in technical jargon, but the implication was clear. The object had not simply been hidden, it had hidden itself. Around this time, a small group of analysts began to connect these events to the theory known as optical suppression. This concept suggests that certain plasma conditions can temporarily bend or scatter light in ways that mimic invisibility. Under specific electromagnetic frequencies, an object can effectively erase itself from view by redirecting incoming light. The few frames captured during the blackout period showed faint lens distortions consistent with that effect. The edges of the sun appeared slightly smeared, as though the space between camera and object had been warped by an invisible field. If 3i Atlas somehow generated or triggered such a field, even unintentionally, it would explain why every camera failed to see it. But there was another explanation, one far less comforting. Some speculated that the coordinated blindness was the result of human intervention. A few independent astronomers noticed that observatory data servers went offline for scheduled maintenance that day, precisely during the blackout. No alert had been issued in advance. When the servers came back online, several gigabytes of observation data were missing. No one could say who authorized the interruption. For the public, the silence was explained as standard system updates. For those who had been watching in real time, it felt like censorship written into code. In the weeks that followed, discussion of the event faded from mainstream channels. The official report cited hardware malfunctions, software resets, and environmental interference. Yet, none of the explanations addressed the deeper question: why did every eye close at the same instant? Some scientists suggested coincidence, but others pointed to timing so exact that it bordered on choreography. If the cameras were blindsided by nature, it was the most coordinated natural accident in recorded observation. What made the incident even stranger was what happened next. After the blackout, several instruments reported receiving ghost images, faint afterglows appearing where no light source should have been. These residual patterns resembled reflections, yet they appeared in parts of the frame untouched by solar exposure. It was as if the cameras, having seen something they could not process, retained its impression. One researcher described it as a photographic memory of an event that was never captured. The phenomenon repeated again 2 days later, when a small group of amateur astronomers attempted to image the same region. Their sensors recorded a dim halo that flickered and vanished. The light did not behave like dust or plasma reflection. It appeared structured, almost geometric, with faint edges forming what looked like parallel lines. None could explain it. The data was archived, debated, and quietly forgotten as attention shifted elsewhere. But the phrase "cameras that looked away" began circulating among those who had studied the blackout. It captured both the mystery and the unease, the feeling that the universe had momentarily forced humanity to avert its gaze. In hindsight, the event now stands as one of the most haunting chapters in the 3i Atlas timeline. Every major telescope, every sensor, every observer experienced some form of blindness. It was as if space itself drew a curtain across the scene. Whether caused by electromagnetic interference, deliberate concealment, or a natural cosmic veil, the outcome was the same. The cameras did not fail. They obeyed something unseen. When the images resumed, 3i Atlas was gone from its predicted location. Its trajectory altered just enough to defy the models. The object had changed course during the blackout. How it did so remains a question without an answer. Some say it was a maneuver, others believe it was an illusion, the product of observational error. But the silence between frames tells its own story. In that silence, the cameras looked away, and something happened that no one can explain. For a few hours, the universe hid its hand, and when it opened again, the evidence was already gone, leaving behind only the uneasy realization that sometimes the most significant moments are the ones that no instrument is allowed to witness. In orbital mechanics, there is a maneuver known as the Oberth effect. It describes how a spacecraft gains more energy when it fires its engine at the point of greatest velocity, usually near a planet or star. It is a simple principle of physics, but also one of the most powerful. By using the gravity of a larger body as leverage, a traveler can bend speed itself. The idea has been applied in countless missions across the solar system. Yet during the passage of 3i Atlas, something occurred that echoed this principle on a scale far beyond what human technology could achieve. It became known as the Oberth shadow, a term whispered among astronomers who believed the interstellar object may have used the Sun not merely as a heat source, but as part of a maneuver. The first hints appeared in the trajectory models. Before the alignment near Mars, 3I Atlas was on a path that seemed predictable. Every simulation showed it following a stable inbound course, decelerating gradually as it approached the Sun. Then, after it crossed behind solar glare, the data shifted. When it re-emerged days later, it was moving faster than expected, as though something had boosted it during the period it was unseen. The increase was subtle but measurable. No natural explanation fit. It did not correspond to any known outgassing behavior, nor could gravitational slingshot models account for the change without invoking artificial control. To understand the mystery, researchers revisited the missing frames and telemetry from the blackout period. The few instruments that continued to collect partial data detected a sharp thermal signature within the solar corona. It lasted only minutes, but indicated a sudden burst of heat far greater than a typical comet flare. The pattern suggested concentrated acceleration rather than evaporation. If this burst came from 3I Atlas, it meant that the object had somehow used the Sun's gravity to amplify a thrust event, performing an Oberth maneuver with unimaginable precision. Yet this would require deliberate timing, awareness of trajectory, and control of energy output. Nothing about a natural comet supports such capability. Some scientists tried to explain it as an illusion caused by observational gaps. They argued that the object's apparent speed increase could be the result of data interpolation errors. But the same deviation appeared independently in readings from two separate observatories, one in Chile and one in Australia, using different instruments and methods. Both sets of data pointed to the same truth. The object had gained an impossible amount of kinetic energy in the short span it was hidden. The conclusion was uncomfortable. Either our understanding of physics had overlooked something profound, or 3I Atlas was behaving as if guided by intention. The term Oberth shadow was coined to describe this event because what happened did not occur in direct view. It was a shadow of the real maneuver, inferred through absence and consequence. The object vanished into the solar light and returned changed, faster, lighter, and more stable. The word shadow fit perfectly because whatever force drove the change left no visible trace, only a silent footprint in the equations. When analysts modeled the potential mechanics, one scenario stood out. If 3I Atlas released a burst of mass in the direction opposite its motion while deep within the Sun's gravitational well, it would gain tremendous acceleration with minimal energy expenditure. This is precisely how the Oberth effect functions. The timing of its trajectory placed it at the exact point where such a maneuver would be most efficient. The alignment with Mars added another layer. If the object used Mars as a gravitational pivot immediately before diving toward the Sun, the resulting boost would send it on a completely new path, one that could appear accidental while being perfectly calculated. As more data emerged, another anomaly surfaced. Instruments aboard NASA's Parker solar probe detected a brief, localized magnetic fluctuation within the solar wind at nearly the same time as the hypothesized maneuver. The fluctuation had the characteristics of an artificial pulse, structured, short, and confined to a narrow bandwidth. It did not resemble typical coronal turbulence. If 3I Atlas had discharged energy to alter its velocity, such a pulse could have been a byproduct. It was a faint signature, but it coincided precisely with the period when every major telescope experienced interference. The idea that an interstellar object could intentionally execute an Oberth maneuver unsettled many in the scientific community. The energy control required would dwarf anything humanity could currently achieve. Even a small burn at that proximity to the Sun would demand materials capable of withstanding temperatures far beyond known limits. Yet the data remained. The numbers refused to align with any natural model. The silence from official institutions only deepened the intrigue. Meanwhile, a few independent physicists began exploring whether such a maneuver could occur without technology. They proposed that if an object had a highly reflective or magnetically active surface, it might exploit solar radiation pressure in complex ways, creating a pseudo-thrust effect when combined with gravitational influence. In theory, this could produce something resembling an Oberth boost, but the calculations required a level of precision so exact that any natural explanation began to feel like a stretch. Coincidence could only account for so much. During the weeks that followed, a subtle pattern of solar disturbances began to appear along the projected path of 3I Atlas. Small coronal jets erupted at intervals matching its trajectory, almost like footprints left behind. The timing between them formed a harmonic rhythm, suggesting a cascade of related events. If the object had used the sun as a lever, these disturbances could represent the wake of that interaction. The sun, enormous and indifferent, might have echoed the maneuver in bursts of magnetic reaction. When the object finally reappeared on the far side, its tail looked different. Observers noted that the dust flows seemed more directed, less chaotic. The sunlight caught it in a way that hinted at symmetry, as though the tail had been sculpted by design. Even the spectrum of light reflected from its surface showed subtle changes. Certain wavelengths were missing, absorbed by something that did not behave like ordinary ice or rock. It was as though the material composition had altered during its time near the sun, perhaps through controlled exposure or deliberate shielding. This is where the story turned from science to speculation. Some believed 3I Atlas was not a natural traveler, but a constructed probe designed to use the Oberth principle as a method of interstellar navigation. Others proposed that it was a fragment of an unknown object that had learned to move with efficiency born from physics alone. The lack of evidence either way made the discussion endless. What remained undeniable was that the maneuver, if real, demonstrated knowledge of gravitational mechanics at a level no random comet could possess. One of the most compelling clues came from timing analysis. The maneuver coincided almost perfectly with a rare synchronization between Earth, Mars, and the Sun, known as superior conjunction. During this period, radio communications between planets are disrupted by solar interference. It is one of the few moments when entire sections of space go dark to human monitoring. If any event were to occur unseen, it would be then. The Oberth shadow exploited that very window, performing its silent act when all channels were blind. The precision was chilling. Months later, when the object began to fade from tracking range, its speed remained higher than predictions. It was now moving with an energy signature inconsistent with simple gravitational ejection. The data pointed to something that had harnessed the sun's power and used it to escape with elegance. If this was a maneuver, it was executed with mastery. If it was coincidence, it was one so exact that it mirrored intelligence itself. The Oberth shadow remains one of the most enigmatic events ever recorded in celestial observation.
No one saw it happen.
No photograph captured the moment. Yet its aftermath is written in the equations, in the altered speed, in the faint echo of magnetic disturbance, and in the silence that followed. It reminds us that even the most familiar principles of motion may hide secrets when applied by forces beyond our understanding. Whatever 3I Atlas truly was, its passage through the sun's gravity left behind a question that lingers in every mind that studies it. Did it learn from us? Or did we glimpse a maneuver far older than our civilization, written into the mathematics of the universe itself? The Oberth shadow is more than a mystery of movement. It is a message hidden in trajectory, a reminder that sometimes the deepest truths are revealed not in what we see, but in what the light allows to disappear. When astronomers first observed 3I Atlas, they expected to see the familiar spectacle that accompanies any comet crossing the inner solar system. Dust and gas streaming away from the sun, glowing faintly under the pressure of solar radiation, forming a tail that always points in the same predictable direction. It is one of the most dependable laws of space observation. The tail of a comet never lies. It tells you where the sunlight is coming from and where the energy flows. Yet in the case of 3I Atlas, the rule broke. The tail pointed toward the sun. The earliest reports came from amateur astronomers who compared side-by-side frames from two observatories taken minutes apart. At first, they believed it was a calibration issue. The bright glow seemed inverted, as if the comet were breathing in rather than out. But when professional images confirmed the orientation, disbelief turned into debate. Solar wind cannot push dust toward the sun. It can bend, twist, or fragment it, but it cannot reverse it. For the tail to move inward, something had to pull it against the force of radiation itself. NASA's Solar Division reviewed the data and attempted to model the phenomenon. The simulation produced chaotic behavior inconsistent with natural outgassing. It would require jets of material erupting from the night side of the object, the side facing away from the sun, firing backward with extreme precision. Such alignment is nearly impossible for a tumbling body. Yet every image showed a smooth, stable orientation. The tail remained fixed, like a compass needle, unwavering for days. Some scientists suggested magnetic interference. They proposed that charged particles from 3I Atlas could have interacted with the interplanetary magnetic field, redirecting dust in unexpected ways. But the strength of that field is far too weak to cause such a reversal unless the object itself generated its own magnetic influence. That would make 3I Atlas not a passive traveler, but an active participant in its environment. The idea sounded absurd until magnetometer readings from nearby spacecraft showed slight anomalies in the same region. For a few hours, the direction of the solar wind itself shifted unnaturally, as if something had bent it. If the readings were accurate, the object was not being shaped by the sun, but shaping the space around it. This interpretation unsettled many because it implied a kind of energy control never before observed in a natural object. If 3I Atlas carried a strong localized magnetic field, it could theoretically guide charged dust streams along its own lines, sculpting a tail that appeared reversed to the observer. In that case, what looked like a simple comet was behaving more like a magnetic engine. When researchers traced the trajectory of the tail's orientation, they discovered an even stranger fact. The angle of the reversed tail pointed almost directly toward Mars. This alignment matched the period when the planet and the object shared their closest geometric relationship. The tail was not simply pointing toward the sun, it was pointing toward a very specific place in the solar system, as if targeting a destination. The realization sent waves of unease through the small community studying the event. If coincidence, it was extraordinary. If not, it was something far more deliberate. The data from the Solar and Heliospheric Observatory captured brief flickers of light traveling along the tail's length, like pulses moving through a wire. The phenomenon lasted only seconds but repeated twice over consecutive days. Spectrographic analysis showed that the light was concentrated in specific frequencies, not the broad scatter typical of dust reflection. It looked like structured emission, possibly ionized particles following magnetic lines. The tail, once thought to be an inert stream of gas, behaved more like a conduit. Publicly, agencies remained cautious. Press releases described the event as an optical illusion caused by perspective and solar reflection. Yet those explanations contradicted the raw imaging data available to independent astronomers. The inversion persisted across multiple viewing angles and instruments. Some images even showed the tail splitting, one part flowing outward, the other inward, as if two forces were competing for control. Nothing like it had ever been documented. The reversal coincided with subtle fluctuations in the solar wind that rippled across millions of kilometers. Instruments near Earth recorded changes in particle velocity that matched the timing of the tail's realignment. The entire magnetic architecture of the local solar system seemed to respond. It was as though the presence of the object had rewritten the normal rules of solar interaction, bending invisible lines of force around itself like fabric caught in motion. A few scientists compared the event to magneto-hydrodynamic propulsion, a theoretical concept once proposed for spacecraft design. In that system, charged plasma is accelerated along magnetic fields, producing thrust without combustion. The reverse tail fit the pattern perfectly. If the object expelled charged particles along its own field lines, it could generate thrust while simultaneously creating an optical illusion of reversed flow. In that interpretation, the tail was not a symptom of heat, but a signature of movement. Still, there remained the question of motive. Why would an object need to direct its energy toward the sun? The simplest answer was control. By releasing mass inward against solar radiation, it could slow itself, adjusting its orbit with subtle precision. This would explain the later deceleration observed as it approached the solar limb. It was performing the equivalent of braking, using the sun's pressure as resistance. The act would be extraordinarily efficient if timed with precision. It would also confirm that the object understood the environment it was navigating. The theory gained traction when researchers noted that the reverse tail disappeared exactly as 3I Atlas reached perihelion, its closest point to the sun. At that moment, the object brightened dramatically and then went dark. The switch resembled the shutdown of a controlled system rather than the chaotic disintegration of a natural one. The light did not fade gradually. It stopped, as if a mechanism had completed its task. When it emerged again from the solar glare, the tail had resumed its normal direction, pointing away from the sun like any ordinary comet. To the untrained eye, it looked as though nothing unusual had happened. Yet to those who had followed every frame, it was a transformation too symmetrical to be dismissed. The object had reverted to a natural state only after completing what appeared to be an intentional maneuver. In the aftermath, debates raged quietly in academic circles. Some insisted the tail inversion was merely a result of viewing geometry and scattering effects. Others countered that multiple observatories in different hemispheres saw the same reversal from distinct vantage points, making that explanation impossible. A few even speculated that the tail's behavior hinted at an underlying artificial core, perhaps a metallic body capable of generating fields. It was speculation without proof, but the question lingered in every discussion. Later, when 3I Atlas began moving away from the sun, telescopic spectra revealed unexpected traces of nickel and cobalt in its trail, elements associated with industrial alloys rather than volatile cometary ice. These metals are rarely found in such proportions in natural bodies. If the reverse tail had expelled this material deliberately, it might have been releasing components of an internal structure. The thought was both thrilling and unsettling. The final surprise came months later when astronomers reanalyzed the scattered light patterns left by the event. They discovered faint oscillations that repeated at precise intervals, like a coded rhythm embedded in the reflection. It was not random noise. The spacing between the peaks matched the rotation period of the object itself. If the tail acted as a conduit for energy, those oscillations could represent modulation, the imprint of a process repeating within. To some, it looked like information. A tail that points the wrong way became more than an optical curiosity. It turned into a metaphor for the entire mystery of 3I Atlas. Everything about it seemed to move against expectation, as though defying the laws written by nature itself. A comet that reversed its tail, aligned with Mars, manipulated magnetic fields, and possibly harnessed solar forces for navigation. Whether natural or not, it behaved like something aware of the environment it crossed. Even now, the images of that inverted stream remain among the most debated in astronomy. They challenge the core assumptions of how matter responds to light and motion. If 3I Atlas was a mere rock of ice and dust, it performed an impossible ballet with the solar wind. If it was more than that, then its reversed tail was not a mistake of physics, but a message written in plasma, pointing toward the one place we least expected to look, back toward the light itself. When 3I Atlas completed its passage near the sun, most assumed the story would end there. The object had survived its solar encounter, changed trajectory, and continued into deeper space. Yet, Within days of its disappearance from direct observation, a strange ripple began spreading through the solar system. It did not take the form of light or heat, but of subtle disturbances, magnetic, atmospheric, and seismic, appearing across multiple planets and even on Earth itself. They were faint at first, almost ignorable, until patterns began to emerge. The timing, the intensity, and the frequency all traced back to one moment, the exact hour when 3I Atlas vanished behind the Sun. Scientists began calling them aftershocks, though no one could say what had caused the original impact. The first sign came from Mars. Instruments aboard the InSight lander detected a vibration that was not geological in origin. It was low, rhythmic, and spread across the planet's crust like a slow heartbeat. Seismologists were perplexed because the signal came from everywhere at once, not from a single epicenter. Mars is quiet by nature, its quakes rare and weak. But this pulse was synchronized, as if the planet had responded to a distant whisper. The frequency of the vibration matched the magnetic oscillations recorded earlier by Manoeuvre during the alignment with 3I Atlas. It was a signature that should not have returned, yet it did, magnified and echoing through the ground. Hours later, Earth's magnetometers recorded their own disturbance. At observatories in Alaska, Norway, and Japan, the magnetic field began to oscillate with a peculiar rhythm that defied the expected pattern of solar-wind interaction. The Sun was calm, with no flares or coronal mass ejections reported, yet the readings spiked sharply. Communication satellites briefly experienced data interference, while auroral activity intensified near both poles without a clear solar cause. The pattern repeated 3 times over 2 days, as though something invisible was sending a wave through the heliosphere. What made the event more unnerving was how widespread it became. The Lunar Orbiter (LRO) detected short bursts of electrostatic activity on the Moon's surface during the same interval. Jupiter's magnetosphere, monitored by the Juno probe, experienced a sudden surge in charged particle density, a 10% increase with no apparent source. Even the Sun's own magnetic field seemed to ripple in response, creating narrow filaments of light that danced briefly and then disappeared. The solar system, vast and indifferent, had moved as one body for a fraction of a second. Something had tied the planets together through resonance. The data suggested that these aftershocks propagated not as mechanical vibrations, but as waves within the electromagnetic fabric of space itself. Some theorists proposed that 3I Atlas might have released a burst of energy or altered field matter during its perihelion maneuver, sending a shockwave outward through the heliospheric plasma. Others suspected that the object's passage near the Sun had triggered a feedback loop between magnetic fields, amplifying oscillations like strings vibrating in harmony. Whatever the cause, the effect was unmistakable. Instruments across the solar system had registered a shared disturbance at nearly the same time. What confused scientists most was the delay. If the energy had originated near the Sun, it should have reached Earth much sooner. Yet the first measurable effects occurred more than 2 days after the object disappeared from visual detection. That lag suggested either that the wave had traveled through a medium slower than light, or that it had been reflected or refracted before reaching us. Space weather models could not explain it. The wave's pattern did not resemble known solar or cosmic events. It pulsed with intent, measured, almost deliberate. At ground level, atmospheric scientists began noticing unusual phenomena. Radio operators reported intermittent signal skipping, where frequencies normally reflected by the ionosphere vanished or rebounded at impossible angles. Schumann resonance monitors, which track the electromagnetic pulse of lightning across Earth, showed a deviation from baseline. The resonance jumped to a higher harmonic, a rare event usually associated with massive solar storms. But the Sun was quiet, the skies were clear. Something unseen was humming across the planet, raising the background rhythm of the Earth's natural electromagnetic song. Even more curious were the seismic correlations. Sensitive instruments detected micro-tremors deep within the crust, not earthquakes, but subtle pressure changes echoing through fault lines. These tremors occurred simultaneously at sites separated by thousands of kilometers. They were too weak to be felt by humans, but strong enough to be recorded. The timing matched perfectly with the magnetic pulses measured in space. It was as if the entire planet had absorbed a wave of energy and responded with a faint shiver. As the pattern persisted, researchers began looking for natural explanations. Some suggested that the sequence was triggered by hidden solar phenomena, perhaps a deep coronal wave invisible to surface imaging. Others invoked coincidence, pointing out that Earth's magnetic field is constantly shifting. Yet the mathematical synchronization between the planetary datasets was undeniable. It was not random noise. It followed an order, a pulse with rhythm and structure. A small group of astrophysicists proposed a more radical hypothesis. They believed that 3I Atlas had not only used the sun's energy for acceleration, but had somehow transmitted information through the solar medium itself. If the object emitted electromagnetic waves encoded with specific frequencies, they could resonate with planetary magnetic fields, producing the aftershocks as secondary effects. The solar system, they argued, might have acted as a receiver. In that interpretation, the aftershocks were not accidents, they were echoes of a message. Skeptics dismissed the idea as pseudoscience. No known mechanism allows for targeted modulation across interplanetary distances without a continuous energy source. Yet the evidence kept piling up. The wave harmonics repeated at predictable intervals, each echo weaker than the last but perfectly timed. When the data was converted into audio frequencies, the signal formed a rising and falling tone that repeated 3 times before fading completely. It was hauntingly symmetrical, like the last vibrations of a struck bell. In the months that followed, the disturbances faded, but their legacy remained. The synchronized anomalies forced scientists to reevaluate how deeply interconnected the solar system might be. Perhaps planetary fields are not isolated bubbles, but parts of a single, resonant web sensitive to disruptions anywhere within it. If 3I Atlas had disturbed that web, the aftershocks were simply the universe adjusting itself back to equilibrium. But the precision of the event suggested more than accident. The energy had passed through every node of the network in perfect order. By the time interest waned, a few researchers had already gone further. They noticed that the harmonic intervals of the aftershocks mirrored geometric ratios seen earlier in the Mars gate alignment. The same proportions appeared again, scaled up across the magnetic frequencies of Earth and Mars. It was as if the pattern had expanded outward, maintaining its structure even as it propagated through space. The idea that an interstellar object could imprint geometry onto planetary systems defied logic, yet the data whispered otherwise. There were other coincidences too. A brief but intense auroral storm struck Earth roughly a week after the first magnetic pulses. Its colors were unusually vivid, dominated by deep red rather than green, a shade rarely seen at that intensity. Cameras captured moving arcs that formed perfect circles before dissolving. Observers described the display as unnaturally smooth, almost artistic. Though officially attributed to minor solar fluctuations, the event carried the same timing signature as the earlier disturbances. To those watching closely, it felt like a closing act, the final echo of something vast. The aftershocks eventually quieted, leaving only subtle residual changes in global data sets. But they raised a question that still hangs in silence. Did the solar system merely resonate to a passing object's physics? Or did something choose to make itself known through the language of fields and frequency? The difference between those explanations is enormous, yet both point to the same unsettling truth. We are not isolated observers in space. Every planet, every magnetic line, every pulse of charged wind is connected in ways still beyond comprehension. Perhaps the aftershocks were never meant as warnings or messages at all. Perhaps they were simply the natural sound of equilibrium returning after a disturbance too great for our instruments to absorb quietly. Yet for those who studied the patterns, the memory remains clear. The planets had responded as one. Space had shuddered, briefly alive with invisible motion, and somewhere beyond the reach of our senses, 3I Atlas moved on, leaving the solar system trembling in its wake, as if the universe itself had felt the passing of something that was never supposed to be here.